Okay, these are the 9-4 notes. You can see me, this is just a proof here of what you were doing today in class. All the radii are congruent. If I know the arcs are congruent, then I know these angles are congruent. Don't assume that A, B, and C, D are parallel. I don't want you assuming that and then thinking that only works when they're parallel, because this works anytime. If I know the arcs are congruent, I know the angles are congruent. And then I can prove the triangle's congruent by SAS. And once I prove they're congruent, I can prove this is congruent to this by CPCTC. The proof down here is going to work in a very similar way. I'm just going to be starting with that this, I can prove the triangle's congruent, then I'll prove the angle's congruent by CPCTC, and then the arcs will be congruent because their central angles are congruent. So it's a very similar proof to this one. In this one, again, I proved that the triangles were congruent with HL, that the radii were congruent. This is congruent by reflexive. These are two right triangles, and therefore these two are equal by CPCTC. Then you can prove the central angles congruent. Once you prove the central angles congruent, you can prove the arcs are congruent. And again, push pause if you need to. On this one, I'll get to this one in class. Basically, it's the same idea of proving triangles congruent. It's a little more steps in between. It's, proving small triangles congruent, then proving big ones. If you got that, great. If not, don't worry, I'll go through that tomorrow. Next, you were to do some examples in your notes. I showed my work here. What you could do is ignore the red, draw the picture if you don't already have the notes, and work through those and then come back and check with this by pushing pause. In this one, I used the right triangle. I also knew that the radius was perpendicular, therefore it's splitting the chord in half. So once I found y was 12, x had to be 12 too. In this example, I have a 30, 60, 90 triangle. So across from the 30 is the 3, and across from the 60 is the 3 root 3. Down here, they're equidistant from the center. So that means these chords are congruent. Also, because this radius is perpendicular to the chord, it breaks it in half. So if this is 8, x is 8, means the whole thing is 16, so y is also 16. Again, push pause. I know I'm going quickly. In this one, I drew some radii in that could be helpful. So if this arc is 86, then this angle is 86. This is 10. This chord is 10. Well, this one is 5 with the radius coming through. So I know x also has to be 5 because the radius is perpendicular to the chord. So if that means AB is 10. Well, if EF is 10 and AB is 10, then they have congruent angles here and congruent arcs. They intercept congruent arcs. So y is half of that, so it's half of 86, which is 43. For this one, you might need the diagram. That might have been a little confusing, but I have a chord. It's 5 from the center. So here's the center. Its distance from the center is 5. The radius is 8, and I'm going to choose to draw the radius to make the right triangle. I'll use Pythagorean theorem to figure out the square root, that this is the square root of 39. So the length of the entire chord is going to be 2 square roots of 39. For the last set of examples, and again, you can pause this, copy them down, work through, and come back and check. RT is going to be 30 because this is a radius perpendicular to a chord. If this is 15, then this side is 15. For OM, I used the Pythagorean theorem since I knew 2 sides, and the work is here. In this circle, the 220, again, is from endpoint to endpoint. So arc ACB is going to have to be 360 minus 220, which is 140. Angle AOC, well, because this is perpendicular to the chord that intercepts it, this is half of angle AOC, so that's going to be 70. Over here, these chords are equidistant from the center, therefore they are equal. Since the chords are equal, they intercept equal arcs, so if this arc is 80, so is this one. Again, this should not take you only the 5 minutes of this video. You should go through and work through each of these individually, and then come back here just to check.